Welcome to Ask and Learn.
The radius of convergence here is r, limit as n goes to infinity of absolute value of an over an plus 1, where an is n over 2 to the n times n squared plus 1. So this is limit as n goes to infinity of n over 2 to the n times n squared plus 1. And then dividing by a sub n plus 1 is the same thing as multiplying by the reciprocal. So multiply by 2 to the n times n plus 1 quantity squared plus 1. And then dividing by n plus 1. So that's limit as n goes to infinity of 2 to the n plus 1 divided by 2 to the n is just 2. And then we can group this n and this n plus 1 together just to make it a little easier to look at. And then we're left with n plus 1 squared plus 1 divided by n squared plus 1. So up here, this is a degree 2 polynomial with leading coefficient 1. Down here, this is a degree 2 polynomial with leading coefficient 1. So as n goes to infinity, this is going to go to 1. And as n goes to infinity, n over n plus 1 is also going to go to 1. So this turns into 2 times 1 times 1, which is just 2. So that's the radius of convergence. For the interval of convergence, we need to figure out whether or not we include x equals minus 2 and whether or not we include x equals 2. So if x is equal to minus 2, then our sum turns into sum from n equals 1 to infinity of n. And then we have minus 2 to the n divided by 2 to the n. The 2 to the n's will cancel. So then we'll just have this minus 1 to the n here. And this n squared plus 1 down here. So then now we're alternating sign if we just plug in x equals minus 2 here. And these terms are going to be going to 0. So the alternating sign test is going to give us convergence here. So now we need to figure out what happens when x is equal to 2. Okay, if we plug in x equals 2 here, this 2 to the n will cancel out with this 2 to the n. And then we're just going to have n over n squared plus 1. Okay, so call these terms our bn terms now. I guess we'll just call them we'll call them bn terms. And then we're going to do the limit comparison test. So we're going to want to compare this to something else. So for the limit comparison test, you want to think about what happens as n goes to infinity. So as n goes to infinity, this plus 1 is negligible. So the terms we'll compare it to will just be n over n squared, and we'll toss out this plus 1. But that's going to be the same thing as 1 over n. Okay, so by construction, we set it up so that we have limit as n goes to infinity, absolute value of bn over cn is 1. For the limit comparison test, as long as you get something that's finite and non-zero here, then whatever happens when we sum up these cn terms, we'll get the same behavior as when we sum up these bn terms. Summing up these cn terms, we get divergence because that's a harmonic series. Therefore, we get divergence when we sum up these bn terms. So x equals 2, we have to throw out of our interval of convergence. As we mentioned, minus 2 works. And by the limit comparison test, we see that 2 does not work. So this is our interval of convergence here.